In this video, we're going to take a look at two more integration area volume questions just to solidify our usage of formulas. Remember, volume, there's only two formulas. Think of them as templates. So pi x squared dy and pi y squared dx. Whenever you have a question, choose the right template and fill in the correct values. Then the question is done. Very simple. Let's take a look at this one. The diagram above shows the region R bounded by curve C with the equation y equals to root ln x over x, and then you have another straight line L, and then you have this complicated looking formula. Find the exact volume as R is rotated completely about the x-axis. We're rotating about the x-axis. This is the axis of rotation. Automatically, one of these templates is the chosen one. The correct answer is this one. Because we are integrating with respect to x, we are spinning this graph around the x-axis. So choose this one, not this one. Here, all we need to know is boundaries. So let's set this question up. Pi y squared dx. Two things you need to fill in, the boundaries and the actual formula itself. Y squared would just be this graph. And when you square it, you will get ln x over x squared. Very nice. What about boundaries? Which part of the curve do you want? Once you spin this, take note of the kind of shape you actually get. So you will get this, and if you were to spin this shape around, you will get something that looks like that. Where this part is being hollowed out. Imagine you have this shape, and then you dig a cone out. So the plan is just to find this entire volume, and you subtract away the cone. Cone, you can use the simple formula of 1/3 pi r squared h. So let's go ahead and find the uncut version of this volume before we subtract away the cone to get our answer. This is just this. Where do you want to go from? From what value to what value? You will have to find this particular point here, and you have to find this particular point here, which is actually given to you already, which is E. So the upper bound is E. What about the lower bound? Very easy. Just find the x-intercept of this graph. Set y equals to 0. 0 equals to root ln x. X is simply 1. So you can do this in your head or at the side of your workings. This is 1. And we're done. Once you have this, the question is 70% done. What comes after this is actually just the grunt work of integrating it. Here, sadly, they say exact volume, so you can't use GC. To integrate this, you have to realize that this is actually like that. So you have to use integration by parts to do this. We have simplified this volume question. We apply the volume formulas, chose the right template. Now you have to fall back on your integration techniques that we have worked so hard to get good at. Doing this by parts, one of this is your u, one of this is your dv dx. So according to LIATE, I should always use logarithm as the u. In this case, this is your u, this is your dv dx. If your u is your ln x, your du dx would therefore be 1 over x. And if this is your dv dx, to find v, it's just integrating this, which would give us, this is x to the power of -2, so integrating it will give you -1 over x. Put this in place, you will get this. Pi uv minus integrate v du. So uv minus integrate v du dx. Here, 1 over x dx. Found from 1 to e. So let's continue. -1 over x ln x minus, so I bring out the minus, I'll get plus, integrate 1 over x squared from 1 to e. This will give me minus 1 over x from 1 to e. Putting in the correct values would give you pi, subbing in e, ln e is 1, so this will give us -1 over e minus 1 over e. Minus away, subbing in 1. Subbing in 1 would give us 0, because ln 1 is 0, minus away 1, so -1. Pi 1 minus 2 over e. This would be this green color stuff before you dig out the cone. Now just find the cone. Very simple. To find the cone, there are a few points that are vital. They are this point, and this point. 3 points. Here we already know is e, so we need to find this one. To find this value here, do is sub e into your equation. So y value would be square root ln e, which is 1, square root 1 over e. So 1 over e. What about here? Here is just the x-intercept of this line, this equation here. So sub in y equals to 0, you'll get x equals to 2. So the volume would be volume of cone is equals to 1/3 pi r square h. What is your r? Your r is this length here, from 0 to 1 over e. So 1 over e. What is your h? The height of the cone is this height here, from 2 to e. So e minus 2. Overall volume will hence be pi 1 minus 2 over e, which is the green bit. Subtract away the cone, 1/3 pi e square, and then on top we have e minus 2. Leaving your answer like that is perfectly fine, but if you like it to be clean, you can expand everything. 2 pi over e minus, here you will get pi e over 3e square plus 2 pi over 3e squared. You can simplify this, and then you realize that I can simplify this too. By factorizing out the pi over e, I'll get 2 plus 1/3. 2 and 1/3, 7 over 3. This will be 7 pi over 3e plus 2 pi over 3e squared. Factorize out the pi, I'll get 1 minus 7 over 3e plus 2 over 3e squared. And this is for the people who really want the expression to look nice. If you're running out of time in exam, leave your answer like that. Good enough. Now in this second question, AJC paper 1, 2012, a diagram below shows region R bounded by the curve and this straight line y equals x minus 10. Find the volume of the solid formed when R is rotated 4 right angles, that means one whole round, about the x-axis. This time round, you will get this funny shape here, this one, and you're supposed to rotate it. So let me just draw it below. So you have this curve that looks like that, and think of it as this shape. Once you rotate this shape, now let me just show you a separate example. What happens when you rotate this shape around the x-axis? Think of it as this thing traveling one whole round. It will form a ring that looks like that, centered about the x-axis. So like that, you'll form this ring. So to figure out what kind of volume you are generating, the shape of the volume you're generating, a good way to do that would be to draw it here and then photocopy what you see on top, just a mirror image. And then join them up with a dotted line. So this is the rotation. This is where the straight line ends. And then you have this part protruding out. So it's a funny looking shape. Where the straight line ends is actually here. And of course you have this point here. And finally, this is also an important point. You have to find these 3 separate points. And how do you do that? Just equate the straight line to your curve. Doing that would get you this. Let me just quickly do it. X minus 10, sub it here. X minus 10 plus 5 gives you x minus 5 square equals to x minus 3. Expand this, I'll get x square minus 10x plus 25 minus x plus 3 equals to 0. X square minus 11x plus 28. 28 is just negative 4 and negative 7, which gives you 11. One of them is 4, the other one is 7. What about this point here? Turning point, you see. To find the turning point, this is already in completed the square form. You write this as y plus 5 square plus 3 equals to x. Think of this as your completed the square form, where this is y, this is your x, and then you can find the turning point, right? This one has been tilted sideways, so the x and y flipped. So the turning point would be -5, 3. This will be 3, and this point here will be -5. So then why do we want to find these 3 points? Is because we want to break this into 2 pieces. The first piece being here. We are interested in finding this trapezoid minus away this peach color here, which will give us the first half, which is just this part from 4 to 7 being rotated. So 4 to 7 rotated is simply 4 to 7 pi y square dx minus away 4 to 7 y square dx. Now the y squares you need to choose properly. This y square would be the pink one, which is actually the straight line, x minus 10 whole thing square. And for this y square, the one we want to deduct away, the negative space, the empty space here, right? We want to deduct this away. We want to dig it out. It would be this blue color bit. To find this blue color bit, once again, you have to go back to the equation and split this curve into 2 pieces. The blue bit and the pink one. Let's find out the equation of the blue color one. Just make y the subject. Y plus 5 equals to plus minus square root x minus 3. Y would be plus minus square root x minus 3 minus 5. Clearly the positive one would be the blue one, and the negative one would be the pink graph. So after we split this into 2, this is no longer the actual graph. The graph would be y equals to -5 minus root x minus 3, and y equals to -5 plus square root x minus 3. So here clearly we are using the blue graph. From 4 to 7, we're using the blue graph. Squeeze in the blue graph. -5 plus square root x minus 3 whole thing square dx. Once we're done with that, from 4 to 7, it's over. Now you need to focus from 3 to 4. What happens when you rotate it? The volume you will get is the rotation of the pink graph from 3 to 4, one whole round, minus away the rotation of the blue graph from 3 to 4, one whole round. Rotation of the blue color curve will generate this empty volume that you're supposed to dig out from the pink color one. So in that case, it's simply pi from 3 to 4 of the pink curve -5 minus square root x minus 3 square. Subtract away, integrate from 3 to 4 of the blue curve, -5 plus square root x minus 3 whole thing square. Once we've found these two, all we need to do is add them up. After which it's just a matter of formality. All you have to do is key this both into the calculator. The first one is shown here, so x minus 10. I'm in parametric mode, so this is why it's still t, but it doesn't make a difference. It's just a variable. So t minus 10 whole thing square minus, because I factorize out the pi. So here I'll get from 4 to 7 as well, -5 plus x minus 3 whole thing square. This value here is 85.346. The next value you see is below 41.888. 41.88. Then all you need to do is add them both up. So this plus this to give you the total volume of 127. Total volume 127. And that's it for this extremely complicated question.